Right. We have seen what natting is. Nat. And at last I finished the class saying there are three types of NAT. That's what I said. There are three types of NAT. The network address translation is of three types. Just to remind you what we have learned, I want to say that the source address of the packet, the source layer 3 address of the packet, the network layer address, the source address of the network layer of the packet is changed to different address, which is what we call it as NAT. To change that, you need to configure the NAT, the source address of the packet. Which address? Is it a source MAC address? No, the source IP address. Where is that IP address in OSI? In network layer. That address is changed from original address to mapped address. Original to mapped. We call this as NATing, network address translation, NAT. And I said there are three types of NAT. Number one, static NAT. I also said this is a one-to-one NAT. Static NAT, one-to-one NAT. Only in this NAT, it is bidirectional. Meaning, not only the original address is translated to mapped address, when the return traffic comes, the mapped address, sorry, not the return traffic, I repeat, it is bidirectional, meaning what? Not only the translation from inside to outside, it is also from outside to inside. That is what it means bidirectional. Meaning, you have inside some private network, 10.0.0.1, 10.0.0.2, 10.0.0.3. And here you got, let's say 20.0.0.1, and you are connected to the internet. And let's say here is some server, for example, Yahoo, 80.0.0.1. Now, what is static NAT? We give a dedicated map address. For example, you're going to tell this router whenever traffic comes from A, whenever traffic comes from 10.0.0.1, you translate it to 20.0.0, let's say 2. See, this 20.0.0.2 need not to be an address on the interface. Do I have this address on the interface? No. ISP has given me for this NATing purpose. See on the WAN facing interface, WAN, WAN, wide area network facing side. This is WAN now. Internet is WAN. On the WAN facing interface, I have only 20.0.0.1. Yeah, there is no 20.0.0.2 on the interface. But this address is given by ISP to me so that I can do this translation. So I'm saying whenever traffic comes from A, he should be given this a dedicated address. This address is not to anyone, only for A. That is why we call it a static NAT or one-to-one NAT. And I said it is bidirectional. What it is? It is bidirectional. What it is? When a traffic someone from WAN sent to this address, it will be translated to this address and packet will come and deliver here. For example, if you are somewhere in the internet and the browsing center, if you say telnet 20.0.0.2, the packet will come here. The source address is, let's say some address. This is 70.0.0.1. You're coming from 70.0.0.1, but you're going to which destination? 20.0.0.2. When the packet comes to this address, the router says, hey, wait, I need to change this 20.0.0.2 to what? 10.0.0.1. Now the router knows where is 10.0.0.1. It delivers here. So NATing is not only for the source address, it is also for the destination address in this case. It is also destination-based NAT. But you don't need to write a destination NAT. If you write on NAT statement, this address should be translated to this. Enough, enough, enough. In Cisco router, it is enough. In other vendor like Palo Alto, it is not enough. You need to do both the direction NAT, bidirectional. But it's not there, it is not bidirectional. In Cisco, it is bidirectional. If you say, whenever packet comes from this address need to be translated to this address, the opposite also will happen. Whenever traffic comes to this address, it will be automatically translated to this. That is why we call it as what? Bidirectional. Static NAT is bidirectional. Two-way. In to out, as well as from out to in. The other NATs that you're going to see, they are not bidirectional. The other NATs that you're going to see, they are not bidirectional. Only static NAT is bidirectional. Did you get this point? Did you understand what is bidirectional? If any traffic comes from 10.0.0.1, it will be translated to 20.0.0.2 and sent out. Likewise, if any packet comes to 20.0.0.2, that will be translated to 10.0.0.1 and sent inside. That is why it is bidirectional. Let me do this and show you now. And then we will go to the other two type of NAT. I have one edge router and I have one inside router. I have one outside. Instead of computers, I'm just taking routers. Nothing wrong with that. And I also want to take some computers. And I'll have a switch to connect to this LAN. I'll call this as inside router. I'll call this as inside switch. This I'll call it as edge. This as outside. Now, IP address I would like to do planning like 20 public 20.00 and red subnetted 24. On this interface 20.001/24. And on this interface I'll say 10.003/24. And on this PC I'll say 10.002/24. And here I'll say 10.001/24. This is the plan. First of all, let us give IP address 10.002. The gateway is 10.003. Am I right? You see 3. You can check it. Done. And let's go to the route. Go to the route. So put no, then see, I'm inside. I'm in the router, which I should name it as inside. So I'm saying inside. And the IP address that we planned is 10.001. Interface G000. IP address is 10.001. See, on the computer we give gateway. How you will set gateway on the router? 2 ways. One, you can write a default route like this: IP route, any network, any subnet mask, send it to 10.003. Whose address is this? 3. Router's address. Then a gateway. That is what gateway, right? So this is one way. You can say any network, send it to this address. Or you can also say IP say default gateway. What is the address? 10.0.0.3. Huh? Anything you can follow. Now, we have configured this too. Let me go to the switch. If you want to give IP address to a switch, you can do. We will not do it now. Just leave it. Switching, we have separate topic. We will do later. Now, on the router, switch you no need to configure. It will work. Host name edge. Interface G000. (10.0.0.3). Now I'm going to ping and see. Why? It will ping now. It's pinging. Okay, it took some time. The reason is the switch needs to learn the MAC address and forward like that. Let me ping the other computer. This will ping first. Okay. So I'm able to ping the LAN device. This is a LAN. This router, all the inside device is a LAN. Local area network. This is LAN. Okay. This is LAN. So LAN devices, they can ping each other. You can go anywhere and ping. You can even ping from this PC to your gateway as well as to the other computer, sorry, the other router 10.0.1. You're able to ping there. LAN is ready. Let's finish the other side. Edge. (20.0.0.1). And the outside router, I'll call it as outside. That's all. Now from here, if I ping 20.0.0.1, I should ping. I'm able to ping. But can I ping 10? Answer me. Can I ping this address from outside? See the topology if you want. Yeah, no. Why? Why outside cannot ping 10.0.0.1? Because there is no root. In the real world, outside networks, outside routers, the ISPs will not have route to the private network. So I'm not going to write any static route or default route on outside. I am not going to write any default route or static route on outside. When you do NATing, the ping will happen. I don't know whether you can imagine what I'm saying. Let me explain. If I ping now from this router, the source address will be 10.0.0.1, and let's say I'm pinging this address. Destination is 20.0.0.100. If I ping from here, by using default gateway, the packet will go here. The router will check the routing table for 20 network. The router knows 20 network, so the router will forward this packet to this router. And here is where 20.0.0.100. See, the packet has arrived from A to B. The packet has arrived. Do you have any question in this? The packet has arrived. Do you agree with me? No natting, packet will arrive. Do you agree? Yes. What about Prem? Packet will come. No problem in coming. But the problem is in returning back. Now you see, B needs to now respond. The packet source will be what? 20.0.0.100. To whom it has to respond? It has to respond to எந்த சாரே எங்க இருந்து வருதோ அங்கதானே சாரே போகணும். நம்ம தான் நாட்டிங்கே பண்ணலையே. 10.0.0.1. We have not done natting. It will try to go to 10.0.0.1, but there is no route. Agree? There is no route. So the packet will not reach back. The reply will not come out. Outside router cannot send the packet because outside router has got no idea. Look at this. I'm going to show you on the outside router. The routing table. See, the router cannot reach because you do not know where is 10. Strong. The ping didn't happen. It is because there is no route. But when I do natting, the ping will happen. Why, you know? When I do natting, when the packet crossed the router, this router, the packet source address will become the mapped address. For example, I'm going to say 10.0.0.1, translate it to 20.0.0.2. So the source will be what? 20.0.0.2. And the destination will be the same. 20.0.0.100. The packet will go here. The router will reply to whom? From where it is coming. Where it is coming? It is coming from 20.0.0.2. Do you agree? This router knows 20 very well. It is in this direction. It will send the packet here. And when the packet comes to this address 20.0.0.2, it will automatically change. When this packet arrives, it automatically changes the destination 20.0.0.2 to 10.0.0.1. The source will remain the same. So the packet will easily come back. You understand what I'm saying? When you have a static NAT, when you have natting enabled, you no need to have any default route or default gateway configured on the outside router. Are you with me? So if that is the case, the ping which is not happening now, you see right now from inside, if I ping 20.0.0.100, I'm not able to ping. This is 20.0.0.100. I'm not able to ping. But after natting, the ping should happen. Why? Because after natting, the source address will not be 10.0.0.1. The source address will be 20.0.0.2. Right now, if you go here, please focus. I'm in the outside router. I'm going to say outside router. கொஞ்சம் அந்த packet எல்லாம் டீட்டெயிலா காமிங்கப்பா அப்படின்னு கேட்குறேன். I'm asking, show me those packets in detail. Debug IP packets. Show me all those packets that you are getting. Now, after enabling this debug, I'll go back and try pinging again from the inside router. See, from the inside router, I'm trying to ping this again. Now you go back here. I didn't see any debug. Edge router. Show IP route. Okay. It has got 21 gigs. Let me try this command. Debug IP ICMP packets. ICMP. Okay. Now let me try ping. Sure. Oh, the gateway is not set. Maybe the simulator, it's not, I have to write a default route, IP route. You remember I gave a default route command, it didn't work. Default gateway command, it didn't work. IP route, any network, any subnet mask, send it to 10.0.0. Okay, I've written a default route. I've written a default route from here to the gateway. Now, please see from inside, I'm going to ping one more time. And I want you to see the debug IP packet. Okay, look now. You will definitely see. Listen, from where the packet is coming now. Who is S? S means what? Secunderabad? What is S means? Switzerland? Source. This source coming to this destination. And EcoReply is trying to go to this destination. But unfortunately, the destination is what? Unroutable. But when you do NATing, the source won't be 10.0.0.1, it is going to be 20.0.0.2. Then it will be a routable one. Do you agree? Let us do NATing now. I'm going to the edge router. First thing is, you need to tell the direction. What? You need to tell what? Direction. This is inside direction. NAT inside. This is outside. Very first configuration, you do this. Many people forget to do this. If you don't do this, whatever you do the other configuration is of useless. So I'm going to say the direction first. Interface G000 IP NAT inside. Easy enough. Direction I have said. Likewise, interface G0/0/1 IP NAT outside. We have defined the direction. This is the very first step that you need to do, and this step is the same step for all three type of NAT. The step is same for all three type of NAT. Okay. Now what? You need to write the actual static NAT statement. IP NAT. Focus. Where am I? I'm in the global configuration mode. But where did I say inside and outside? Under the interface. Exactly. Inside and outside, you should say under the interface. NAT statement should be written in the global mode. Okay. See, I'm in the global mode. IP NAT, I'm saying inside. What does that mean? You know, traffic coming from G000. That is inside. Here only we have said inside. So that's the meaning of this inside. Source is what? Static. Source static. What address? this router 10.0.0.1 address. If this is the source, to what address you need to translate? See, what is the global address? Because of the inside, don't get confused. Traffic coming from inside, it need to be translated to a global address. What is that address? 20.0.0.2. That's all. Easy? Okay, now you see. After that, this is the verification command, show IP NAT translation. You see, it says that if any packet coming from local, before sending to the global, I need to remove this address and put this address. Now let us ping. Ready? This ping will work now. It works. It works. Now you go to the outside and see. You see that traffic was coming from where? Traffic was coming from which source? 20.0.0.2. That is the mapped address to 20.0.0.1. So internet is not seeing your original address. It is seeing your mapped address. So the reply is now going to 20.0.0.2, not 10.0.0.1. Did you get that point? Did you understand? Okay. I'm stopping the debug by typing you all. I would like to show you that translation on the edge router. Earlier when I was typing show IP NAT translation, you saw only this line. But now, you see, it says I translated 10 times because two-way, no? Two-way communication, right? When you ping, it may be 5 packet. It may be a 5 packet, but the reply packet is also there, not the 5 packet. I say it's bidirectional. So, whenever the packet was come from 10.0.0.1, it got translated. What type of protocol was that? I was pinging, so it is ICMP. Did you get this? Did you understand? Ah. Now, from here, if you ping the 20.0.0.2, see, this address is nowhere on the interface. Do we have 20.0.0.2 on the interface? No. But it is in the map table. In map table, you have say 20.0.0.2 means it should go to 10.0.0.1. So when you go here and ping 20.0.0.2, actually it is going to whom, you know? To whom it is going? 10.0.0.1. But the outsider will not know. Outsider thinks that he is talking to 20.0.0.2. But you go to inside and ask, debug IP packet. You see, this is the guy who is going to get the packet. I am pinging from outside. But who is receiving the packet? Who is receiving the packet? 10.0.0.1 is receiving the packet inside. So it's a kind of kannamuchi. It's a kind of hide and seek. It's a kind of security. வெளியில் இருப்பவனுக்கு ஒரிஜினல் அட்ரஸ் தெரியாது, இது யாருக்கிட்ட போதுன்னு தெரியாது. அவனை பொறுத்தவரை 20.0.0.2 தான் பேசுறேன்ட்டு நினைச்சுன்னு இருப்பான். ஆனா 20.0.0.2 யாருமே இங்க கிடையாது. There is none called 20.0.0.2. The router takes all the packet that is coming to 20.0.0.2 and translates it to 10.0.0.1 and sends to 10.0.0.1. So some people claims that NATing is also a kind of security feature because our original address is not revealed to the outsiders. You got it? Any question? Practice